Welcome students again into the 12th science chemistry class. We are learning from few lectures the chapter number 1 solid states. Into that we in the last lecture formulated some formulas, that is the radius of the unit cell, how it is calculated for the cubic crystal, simple cubic crystal, as well as that is the BCC, body centered cubic crystal, and face centered cubic crystal, and how the packing efficiency is calculated. This also we learn. Now today we are going to solve the problem number 1.3. What is in that problem? The unit cell of metallic silver is FCC. That means the metallic silver unit cell is of the FCC type, face centered cubic cell. If radius of the silver atom is 144.4 picometer, radius of the silver atom is given 144.4 picometer. Calculate, we have to calculate now edge length of the unit cell, that is A, because we are always represent the edge length by the small a. We have to calculate the small a of the unit cell, and also volume of the silver atom also we have to calculate, volume of one silver atom, and from that the percent of the volume of a unit cell, that is total volume of the that is all the particles present into the FCC, that is in the percent we have to calculate, and that is occupied by the silver atom, that is percent of the volume of unit cell that is occupied by the silver atom, that means the total volume of the silver atoms, and the percent of the empty space also we have to calculate. Now first let us calculate the edge length of the unit cell. Now edge length of the unit cell is calculated as we know this formula for the face centered cubic crystal unit cell. What is radius is equal to r is equal to root 2 divided by 4 into 8. Now the radius, the formula for the radius of the face centered unit cell is root 2 divided by 4 into 8. Now what is the value of root 2? Root 2 is equal to 1.414 divided by 4 into this 8. So this comes the value 0.3535a. That means r is equal to 0.3535a. Then what is a? A is equal to r divided by 0.3535. That means first we have to calculate now if the value of the radius is known. Now here value of radius is given, but the radius is 144.4 picometer. Now that is equal to 144.4 into 10 raised to minus 12 meter, because 1 picometer is equal to 10 raised to minus 12 meter. So 144.4 picometer is equal to 144.4 into 10 raised to minus 12 meter. And if this is converted into the centimeter, what is the value? 144.4 into 10 raised to minus 10 centimeter, because 100 centimeter is equal to 1 meter. So on multiplying this value of the meter by 100, we obtain the value 144.4 into 10 raised to minus 10 centimeter. So this formula, that is radius is equal to 0.3535a. So radius is the value of the radius is 144.4 into 10 raised to minus 10 centimeter is equal to 0.3535a. Now we have to calculate the value of the edge length. This is the radius. R is equal to 0.3535a. So A is equal to this radius, the value of the radius divided by 0.3535, and this value comes 4.085 into 10 raised to minus 8 centimeter. If you calculate this value by using the logarithmic table, only just see the log of 144.4 and subtract the log of 0.35 from that, and then see the antilog, and this is adjusted by giving the point. So the edge length is equal to 4.085 into 10 raised to minus 8 centimeter. Now first calculate the volume of the silver atom. We have to calculate the volume of the total unit cell, that is AQ, and that can be obtained by taking the this cube of this value, that is the total volume of unit cell. But to calculate the volume of the particles, that is the atoms in the FCC, first calculate the volume of silver atom, one silver atom. And we know that in the FCC there are the 4 particles or 4 spheres, that is atoms. So on multiplying the value of volume of one silver atom by 4, we obtain the volume of the 4 particles occupied into the unit cell. So volume of silver atom is equal to, that is the formula of the sphere, that is the volume of the sphere is 4 by 3 pi r cube. Now here radius is given, so 4 by 3 pi means 3.142. The value of the pi is 3.142, and just take the cube of this radius 144.4 into 10 raised to minus 10 centimeters cube. Now on solving this, we obtain the value of the volume of one silver atom is equal to 1.261 into 10 raised to minus 23. This is also calculated by using the logarithmic table, by taking the logs of all these 4, 3.142, 1.44.4, 3 times the log you must add, and then subtract the log of 3 from that because it is divided, and then see the antilog. Then you obtain this value 1.261 into 10 raised to minus 23 centimeter cube. This become 10 raised to minus 30, and then on adjusting the points, and this is the centimeter cube. So here is also the unit centimeter cube. Now in FCC, phase center element cell, there are the 4 silver atoms. There are 4 silver atoms. Therefore, the volume occupied by the 4 silver atoms is equal to 4 into this volume of the one atom of the silver, that is 4 into 1.26 into 10 raised to minus 23 centimeter cube, and this value comes nearly about 4.044 into 10 raised to minus 23 centimeter cube. Now this is the volume occupied by the particles in the phase center cubic unit cell of silver. Now let us calculate the total volume of the unit cell, and then we have to calculate the that is the percentage of the volume of the unit cell by using the formula, that is volume of the atoms present into the FCC divided by total volume of the unit cell into 100, and on subtracting that value from the 100, we obtain the percentage of the empty space. So let us calculate first the third point, that is the percent of the volume of the unit cell that is occupied by silver atom. But for that we have to first calculate the volume of the total unit cell by taking the cube of the edge length, that is value of edge length is here, we calculated this, and this by taking the cube of this value we obtain the total volume of the unit cell. Let us calculate. Now first let us calculate total volume of the unit cell. Now total volume of unit cell is obtained by taking the cube of the edge length, A cube, and that is equal to 4.085 into 10 raised to minus 8 centimeters cube, because the value of edge length we calculated, that is 4.085 into 10 raised to minus 8 centimeter. On taking the cube of this value, we obtain the volume of the total volume of the unit cell, that is equal to 6.817 into 10 raised to minus 23 centimeter cube on taking the cube of the value. Now this is the total volume of the unit cell. Now percent of volume occupied by silver atom is calculated as, we know the formula. Now percent of volume occupied by the silver atom is equal to volume occupied by atoms in the unit cell divided by total volume of the unit cell into 100. Now the volume occupied by the atoms we calculated just by multiplying the 4 atoms of silver into the volume of the one atom, and that value is equal to 4.044 into 10 raised to minus 23 centimeter cube, and divide this value just by the total volume of the unit cell, that is 6.817 into 10 raised to 23 into 100, and this value comes, that is the 74%. Now the percentage of the empty space is calculated by subtracting the that is percentage of the silver atoms or percentage of the volume occupied by the silver atoms from 100, and that is equal to 100 minus 74, that is equal to 26% is the empty space. Now this phase center cubic unit cell is the most that is compactly arranged, that is the unit cell. Into that there are the 4 atoms, and so the empty space is minimum in the phase center cubic unit cell. Now let us learn the next problem. Now let us learn the problem number 1.6. What is this problem? In this problem we have to calculate the octahedral, number of octahedral voids and number of tetrahedral voids. In the phase center cubic unit cell, both voids are there. Now we know that the tetrahedral voids are always, that is the 2 times of that of the number of atoms present in the that is compound, and the number of octahedral voids are same as that of the atoms present in that compounds or unit cell. Now the problem is a compound forms HCP structure, that is the face center of or hexagonal close packed structure. Now in HCP structure there are the 2 types of the voids, the tetrahedral voids and octahedral voids, we know that. So what is the number of octahedral voids, tetrahedral voids and total number of voids in the 0.4 mole of it. Now 0.4 mole, in that how many atoms are present, this we have to calculate first. We know that the 1 mole of any compound always have the Avogadro's number of particles or atoms. Now Avogadro's number Na, capital N A is equal to 6.022 into 10 raised to 23. So as 1 mole contains 6.022 into 10 raised to 23 particles, then 0.4 mole contains 0.4 into 6.022 into 10 raised to 23, that is the cross multiplication. So the number of atoms present in 0.4 mole of compound is equal to 4 into Avogadro's number. 0.4 into Avogadro's number, because 1 mole corresponds to Avogadro number, that is the Na. So 0.4 mole corresponds to 0.4 into Na divided by this one. So it is 0.4 into Na, but the value of the Avogadro number is 6.022 into 10 raised to 23. So on multiplying 0.4 into 6.022 into 10 raised to 23, we obtain the value 2.4098 into 10 raised to 23 particles. Now these are the atoms present into the 0.4 mole of the compound. Now the octahedral voids are same as that of the atoms present into that that is the compound, given compound. So the number of octahedral voids in that unit cells are equal to the number of particles. So here also number of octahedral voids is equal to number of atoms present into 0.4 mole, and that is equal to this 2.4098 2.4098 into 10 raised to 23. These are the octahedral voids. Octahedral voids present into that 0.4 mole of the compounds, because their numbers are same as that is the number of the particles. Now, number of tetrahedral voids are always double or twice of that number of atoms or particles. So, 2 into number of atoms, this value will give the number of tetrahedral voids. So, 2 into 2.4098 into 10 raised to 23, that is equal to 4.818 into 10 raised to 23. These are the tetrahedral voids. Now, these are the value of the tetrahedral voids. Now, they ask us again to calculate the total number of voids. So, the octahedral voids value plus tetrahedral voids value gives the total number of voids. So, 2.409 into 10 raised to 23 plus 4.818 into 10 raised to 23. This comes 7.227 into 10 raised to 23. These are the total number of voids present. Now, let us learn the next problem. Into that, we have to calculate the formula of the compound from the number of particles of the two different elements. Let us learn this that problem also. Pay attention, students, on the blackboard. Now, this is the problem number 1.2. A compound made of elements C and D. The compounds which contain the two different elements C and D and crystallizes in FCC structure. That means the compound have the two different elements C and D, and the unit cell have the face-centered cubic structure of that compound. Now, this is the compound, because compound is formed by the two or more elements. So, C and D are the elements which form the compound, and the unit cell is of the FCC structure. Atoms of C elements are present at the corners of the cube, and atoms of the D elements are at the center of the faces of the cube. Then what is the formula of that compound? Now, this is the new problem. We know that in the face-centered cubic unit cell, there are the 6 faces, and each face contributes the half particle. And therefore, the total number of particle becomes 1/2 into 6, that is the 3. So, the faces of this FCC totally contain 3, that is the D particles. And corner, there are the 8 corners of the FCC, and each corner atom contributes in the unit cell is only 1/8 part. So, 8 into 1/8, that is the 1 particle. So, C particle is 1 and D particles are 3. Then the formula will becomes CD3. Now, this we easily calculated orally, but how to write this problem? See here. Now, solution. C atoms are present at the 8 corners. So, contribution of each corner atom to the unit cell is 1/8 atom. Therefore, number of C atoms in unit cell, number of C atoms in unit cell will be 8 into 1 divided by 8, that is equal to 1. Now, this is the atom of the C element, 1. Now, D atoms are present at the centers of 6 faces. Each face contributes 1/2 atom. Therefore, the number of D atoms is equal to 6 into 1/2, that is equal to 3. And as there are the 1 C atom and 3 D atoms in the unit cell, therefore, the formula of the compound is CD3. In this way, we can also calculate the formula of the given compound by calculating the number of atoms of the two different elements, which atoms are present at corners or at the face of the unit cell. Now, this is the new problem. Now, let us learn again one problem. Now see students, this is the new problem, problem number 1.4. Into that, they give us the CCP type of structure. CCP means HCP, similar, that is the phase center. A compound is formed by two different elements, A and B. There are the two different elements in that compound, A and B. The atoms of the element B forms CCP structure, that is the HCP or FCC, phase centered cubic structure. The atoms of A occupy 1/3 of the tetrahedral voids. That means the unit cell is of the B atoms, B elements atom, and the A elements atom occupy the tetrahedral voids, but only 1/3 of the tetrahedral voids. Now we know that the tetrahedral voids are same as that of the number of particles in that unit cell. But out of that, only 1/3 of the elements, 1/3 of the tetrahedral voids are occupied by the element A. Then what is the formula of the compound? Now this is the problem. Now we know that the atoms of B element form the CCP structure. Therefore the number of tetrahedral voids is equal to 2 into number of B particles. Okay. Now the number of particles, suppose of the B are the B. So 2 into B, that is the twice B are the number of particles or atoms. B are the particles and 2 into B are the tetrahedral void, because tetrahedral voids are twice of that of the atoms of the B. Suppose there are the total B atoms of B element, so the number of tetrahedral void becomes 2 into B, that is equal to twice B. Now these are the total tetrahedral voids are there. Now atoms of A occupy only 1/3 of the tetrahedral voids. So 1/3 of tetrahedral voids means the number of A atoms are 1/3 of the tetrahedral voids. So 2B into 1/3, that is equal to 2 by 3B. That is the 2 divided by 3B. These are the number of A atoms. These are the A atoms. Number of B atoms are only B, and tetrahedral voids are twice B. These are the value of tetrahedral voids. But the number of B particles we taken as only the B, that is 1B suppose. So 2 divided by 3 will become the number of A atoms. Here we can write the number of B atoms is equal to B, or 1B suppose. 1B. Then the number of A atoms are there, that is the 2/3 of B. These are the number of A atoms, and 1B is the number of B atoms, and twice B are the tetrahedral total voids. Now the ratio of A and B atoms. Now these are the 1B of the B atoms, and 2 divided by 3 are the A atoms. So the ratio of A and B atoms will becomes 2 divided by 3B as to 1B. Now this B get cancelled, that is 2 divided by 3 as to 1, and that becomes 2 as to 3, because 3 into 1 3. So 2 as to 3 are this is the ratio of A as to B, that is A and B atoms, that is the 2 as to 3, and therefore the formula of the compound becomes A to B3, because there are the 2 as to 3 is that is the ratio of A and B atoms. So the formula of the compound A to B3. Now this is the new problem. Into that we can calculate the formula from the that is the number of voids, and by on calculating that voids, the number of, that is the particles of two different elements, and we can calculate the formula of the compound. Now if students, you like this video, you understand this video of the numericals very well, then you can like, subscribe and share this video, and also you can tell the another students to like, share and subscribe this video, because this is very important video All these are the numericals or problems on that of the this unit cell, that is different unit cells. We calculated into that the edge length, the radius, the volume of the total unit cell, again the volume of the particles. Then and also we can calculate the number of voids also into these different problems, and from that we can calculate the this that is the formula of the compound. Such types of problems are always there into the entrance examinations such as CET, NEET and JEE. So this video is very important, and watch twice or thrice times up to you understand all these, that is the problems, and subscribe this. Thank you for watching the video.